This section introduces best practices related to the security of analytics workloads. The first group of best practices falls under the category of classify and protect data. This category contains 6 best practices that focus on classifying and protecting data in analytics workloads. To properly classify data, you first need to understand the data classifications and the affiliated protection policies of your organization. Once you have determined the possible classifications, allow the data owners to classify the data and define the access rules based on the sensitivity and criticality of the data. Next, identify security zone models to isolate data based on classification by designing security zone models, beginning at the AWS account level and extending down to the AWS resource level. Finally, identify sensitive information and define your protection policies. Identify the owners of the source data to confirm the classification of their data. As data moves through the analytics workflow, these classifications will ensure that the data is appropriately protected from unauthorized access by personnel or systems. The data catalog is only useful if it's up to date. An up-to-date data catalog will provide an accurate and reliable record of data locations and classifications, which allows for more effective protection of potentially sensitive data. Encrypt workload data in accordance with the policies that govern the classification level. Implement encryption policies for both data at rest and data in transit. You can find AWS service-specific implementation guides on the AWS documentation website. While your organization might have a standard data retention policy, you should also implement classification-based retention policies. Create your backup requirements and policies based on data classifications. You can also create data retention requirement policies based on the data classifications and tailor your policies to individual assets based on retention requirements, taking care to avoid blanket retention policies. Remember that other data-consuming systems will access the data that your analytics workload shares. Because of this, you should require those downstream systems to implement the appropriate data classification policies. Have a centralized, shareable catalog with cross-account access to ensure that data owners manage permissions for downstream systems. Periodically verify that any downstream systems are eligible to process data at the appropriate level of classification. The next group of best practices is categorized under the title of Control the Data Access. In general, an analytics workload will consolidate multiple data sets into a central location. It's important to identify which person or group owns which data set in order to coordinate data access permissions and ensure those permissions adhere to the principle of least privilege. To federate with IAM by using AWS IAM Identity Center, the successor to AWS Single Sign-On, or another identity provider, a best practice is to centralize your workforce identities. As much as possible, limit access to data stores that contain sensitive data using control mechanisms such as role-based access control, or RBAC. Another best practice is to implement dataset-level access controls by building analytics workloads to have the dataset owners control the data access per dataset level. Finally, implement column-level data access controls and enforce the masking of sensitive data through the use of column-level restrictions. This practice will help ensure that end users of analytics applications are not inadvertently exposed to sensitive data. Though unlikely, automated processes and pipelines can experience occasional issues. You can remediate such issues more efficiently by expediting access through the use of emergency access. Ensure that risk analysis is done on your analytics workload by identifying emergency situations and a procedure to allow such emergency access. As you identify risks, prioritize each event based on likelihood and overall business impact level. The final group of data analytics best practices are categorized as control the access to workload infrastructure. Through the use of services such as IAM, you can ensure that your environment is accessible while adhering to the principle of least privilege. Prevent unintended or unauthorized access to your infrastructure by granting the least privilege possible. IAM provides AWS Identity and Access Management Access Analyzer tool for all AWS accounts that are centrally managed through AWS organizations. IAM Access Analyzer aids you in setting and verifying permissions and assists you in refining those permissions by removing unused access. Identify your source and downstream users and systems, and then identify the minimum privileges that each would require and implement only those permissions necessary. You can further secure access by implementing the two-person rule, which can help you prevent unauthorized access, altering, or even deletion of critical or classified information by requiring the presence of two separate users to perform tasks that you deem critical. Monitor infrastructure changes closely. Practices such as implementing a change control board or change advisory board can be helpful to prevent potentially disruptive or harmful changes. A number of AWS services are available to assist you in monitoring and logging those changes. While services such as AWS Config and CloudTrail can provide you with a wealth of audit logs, these records are useless unless they are also securely handled and maintained. Use fault-tolerant storage for your logs and restrict access to the logs to privileged users. Let's look at how to apply some of the security best practices from the AWS well-architected data analytics lens to a typical stream processing pipeline. To classify and protect data, you can begin by understanding your data classifications and your protection policies before the data is processed in your pipeline. This best practice will govern how you handle all of the data that flows through your data pipeline. Next, identify who the owners of your datasets are and request that they properly classify their datasets if they haven't already done so. As data is ingested into your pipeline, record data classifications into the data catalog and keep your data catalog up to date so that you have accurate and reliable records of data locations and classifications. After you identify the source data that you will work with and have established the classification level of each dataset, you will need to implement the applicable encryption policies. For data at rest, use one of the multiple encryption options available in Amazon S3. Secure your Amazon Kinesis data streams with server-side encryption by using AWS KMS. Additionally, you can use classification-based retention policies for your datasets. Back up and retain analytics datasets based on your organization's policies for classified data. Finally, ensure that downstream services, storage services like Amazon Redshift, and downstream workloads honor your data classifications. If confidential source data enters your pipeline, handle the output of your pipeline as confidential data. To control data access, allow owners of the operational data shown in the diagram to determine which people or systems can access data in analytics and downstream workloads. Implement IAM to control which users, roles, or services can access your resources. Every service shown in the diagram integrates with IAM and should be correctly configured to do so. The operational data in this diagram is classified as sensitive, which means that appropriate control measures must be put into place to adequately secure the data. Finally, each service and resource in the pipeline should have emergency access controls implemented to expedite access to your workload in the event of an issue with your pipeline. Controlling access to the pipeline infrastructure can be done in a number of ways. Implement IAM to control user, role, and system access to the data and services within your workload, and isolate your network as much as possible. After you have identified your source and downstream users and systems, identify the minimum privileges that each would require and implement only those necessary. Once you have secured access to your operational analytics pipeline, it's vital that you monitor it for infrastructure changes and malicious activity. Finally, secure the audit logs for all of the services in your operational analytics pipeline and the services that support it. Ensure that you maintain adequate log security over a fault-tolerant storage solution, such as Amazon S3. Here are a few key points to summarize this section. Honor the data classifications and protection policies that the owners of the source data assigned. Secure access to the data in the analytics workload. Share data downstream in compliance with the source system's classification policies. Ensure the environment is accessible with the least permissions necessary. Automate auditing of environment changes and alert in case of abnormal environment access.